All right, so this is that example I was talking about that one of your cons is based off of. So watch this video before you attempt the con that is finding the inverse of rational functions. This here is an example of a rational function. Basically, it's composed of two different polynomials separated by a division symbol. So to find the inverse, you still do it the same way that we would for a linear function. You would change f of x into y, and then you would switch your x's and your y's. Now, when you switch your x's and your y's, you will notice that you have two y's now, one on the top and one on the bottom. And so in order to solve for y, basically get y by itself, is you basically need to figure out, one, how to condense those y's down to where it's just one y value, but also how to start how to get y out of the denominator. So just like before, we want to multiply both sides by the denominator to cancel it out here, okay? By doing that, we'll have 1 minus 5y times x is equal to 3 plus 4y. So far, one of our tasks is done by getting rid of the denominator. But now I have y's on both sides of the equation, which I can't have. I need my y's to be on the same side. Unfortunately, if I try to divide both sides by x, now I'm dividing this 4y by an x, then it's going to pretty much create an issue. So instead of dividing, distribute the x to both sets of parentheses. By doing so, I'll end up getting x, because 1 times x is x, and then minus 5xy equals 3 plus 4y. And by doing that, this will allow me to get my y's on the same side by adding 5xy over to the right side and subtracting 3 to the left side. So then I'll end up with x minus 3 equals 4y plus 5xy. Now my y's are on the same side. Granted, I can't combine them because one is just a regular y, the other one is an xy. But what I can do is I can factor out a y from both of those terms. And now I just have one y. And now that I just have one y, I can divide both sides by 4 plus 5x. And now I have my inverse function. This is how you find the inverse of rational functions. This is what I was saying, that's a level 3 type when it comes to finding the inverse of different functions. The linear ones was like a level 1. This here is a level 3. Again, get the y out the denominator, which is what I did in the orange. Distribute over the x, which is what I did in the pink. Get your y's on the same side, which I did here in this line. And then factor out a y from both terms, which is what I did going from this line and up.